Alright guys, in today's video we're going to look at linear inequalities. Alright, now in the first video here I just want to talk a little bit about some of the basics, what an inequality is, what a linear inequality is, what the answer should look like, how we represent it, how we graph it. Alright, so let's just start with something simple. Let's start with x is greater than 3. Now this is obviously an inequality because it's saying that something is greater than or less than something else. It's not equal to. Alright, and so x is greater than 3. You could probably name some values right now that would work for x. Okay, 4, 5, 7, 300,000, 3.23, right? There's an infinite number of values that are greater than 3. Okay, so one of the ways that this can be represented is by using a number line, a graph. We only have one variable, so we don't need our coordinate plane with x and y. We only need the x, and so essentially that's what it is. It's just an x-axis or a number line. Okay, where we go from 0, 1, 2, 3, 4, and so on, and then obviously in the other direction as well. Now, we want to demonstrate the fact that x is greater than 3, okay? So we want to make sure that our answer includes numbers like 4 and 5 and 7, which will be farther down here, and 3.1, right? We want to make sure that all of these things are included. All right, so all of those will be part of our answer, and we're going to shade all of those numbers that are greater than 3. Now here at 3, okay, we want to make sure that we get as close to 3 as possible, but not include 3, because 3 is not bigger than 3. But 3.000000001 is. So we got to make sure that we get as close to 3 as possible. And the way that we do that is we draw an open circle here at 3. And that means that it gets really, really close to 3, but it never quite gets there. Okay? And so this graph right here, with the open circle at 3, and then an arrow going to the right, would represent all of the values that work for x here. All right? Let's look at another one. Okay? Let's look at maybe x is less than or equal to -2. All right, can you think of some numbers that are less than or equal to -2? Hopefully you're thinking of numbers that are more negative, right? Again, if we draw our number line with 0, 1, 2, 3, -1, -2, -3, -4, what numbers are less than or equal to -2? And obviously -3 is less than -2. So is -4. So is -3.5. So is -2.5, right? All of these numbers down here are less than -2. Now this one's a little bit different because we have this being as less than or equal to, which means we want to this time include the -2 because -2 is less than or equal to -2. Is it less than? No, but it is equal to. And so we want to make sure to include that and everything below it. And so this graph right here would then represent x is less than or equal to -2. All right? Now, something that some people have a hard time with is, well, what if this is written the other way? What if I see it as 3 is less than x? And some people get confused because they're used to writing things that are less than. Okay, but if you think about this, this is saying that 3 is less than whatever x is. So again, what can x be? Well, x can be anything that's bigger than 3, right? And so this would again look very similar, or actually exactly the same as the one up above, right? I'm sorry these aren't spaced perfectly, but you get the idea. Again, we want to make sure that we include anything that's bigger than 3, because all of those would make my x value bigger than 3. You don't believe me? Well, how do we check any equation? Well, we check any equation by plugging in the solutions. So you take any solution, anything in this shaded area, no matter how far up it is, you plug it in for x, and does that work? Well, yes it does.